Hello, it's David from David Savoury Electrical, and this video is a follow-up to one last week where I made a boo-boo on a surge protection installation. Today I'll be looking closer at these products, how I got it wrong, and answering a lot of the questions and comments from the previous video spewed up from all you fellow drunk and or drugged up electricians out there. Now remember, I'm no authority on this stuff, merely a gutter sparky, mainly house bashing for a living, which is why I'm prone to making the odd cock-up or three. So although I hope to provide some answers and advice in this video, you should always assume that I'm perfectly fallible and I may say something wrong. If I'm pulled up on a mistake in any video, I'll amend the description, so always check there for updated information. Let us begin by reviewing the Luden product I installed last week and by answering the #1 comment left on that video. My complaint upon installation was that the larger cable entry knockout was on the opposite side of the enclosure to where the tails were likely to enter. There are two knockouts on this thing, a 32mm which is ideal for a tails gland which is on the left, and a 25mm on the right above the main switch where the tails are likely to enter. Now I wanted to show this thing as it came out of the factory, so I had to bung my tails gland on the left and bend the tails around to the main switch on the right. Not ideal. There are a slew of comments suggesting I could either spin the DIN rail 180 degrees, use a cone cutter to enlarge the 25mm hole to a 32mm, or to rearrange the layout of the components on the DIN rail so that the main switch was on the left. I showed in the video that the DIN rail wasn't central to the enclosure, so spinning it around 180 degrees wouldn't work, as the lid won't go back on unless that too is inverted, and that leaves it rather like an Australian hooker, upside down and with the flaps hanging open. Not exactly the appearance of a professional install. I could enlarge the 25mm hole to 32mm, and I could rearrange the components on the DIN rail. I had thought that the main switch was specifically labelled with line and neutral sides, meaning rearrangement would be problematic with the buzz bar, but it's not. The terminals are simply labelled 1, 2, 3 and 4, so shuffling the gubbins around is perfectly possible. But my question really was, why should I have to make alterations to this thing as supplied off the shelf? As an installer, I just want to wang it into place and move on to the next job. So breaking out the drill or reconfiguring the layout is something that holds up my packing away the toolbox and scooting off down the pub. I had a call from Luden's technical department on Monday and they acknowledged that it wasn't ideal as configured. It seems they used an already off-the-shelf enclosure for the task and didn't consider that installers may wish to use a 32mm tails gland. I'm told that future batches will be rearranged differently with the main switch on the left, which is great news, and I will rearrange this unit myself later on, ready for when I come to install it. Speaking of the tails gland, I mentioned in my vid that they're a bit of a monster, so my thanks goes out to Juice Electrical Services on Twitter for making me aware of the Whisker TKS32, a low-cost, low-profile 32mm gland capable of accepting up to two 25mm tails and two 16mm earth conductors. Make power smile? Oof, 2 out of 10 for that tagline, Whisker. But how have I never come across these things before? It just goes to show if you get used to a thing, then you don't necessarily shop around too much to see if there are other alternatives available. So let's go back to my installation error. Where I've installed SPDs before, and there haven't been many, they've been installed within the CU enclosure. A Type 2 unit protects a whole installation from the likes of indirect lightning strikes. That's the kind we're talking about here, and they're installed in parallel with the installation. If located in the CU enclosure itself, then it may be off the main switch or off an MCB. On this job I had an existing consume unit which I couldn't modify and which I didn't really want to have anything to do with, so I was installing my SPD in a separate external enclosure. My original intention with this thing was to connect it in line with the tails, so that the main switch in the Luden board would have acted as an isolator for the entire installation. This is the best way to install an external SPD product, as we shall look at later, but when I got to site, my concern was that a 25mm tail entering the same clamp as this neutral wire might make for a poor connection, even if torqued up. In fact, let's try that. Okay, you bloody pedants, my tail offcut is brown and I'm putting it in with the neutral here. Just try and pretend it's blue for goodness sake, for the sake of argument. So we've got the torque screwdriver set to 2.5 Newton meters, which is the requisite tightness for this thing. I'm going to try and share this terminal between both of those wires. Oh, crikey. There we go. Clickety click. All looks okay. But the neutral has or can pop out, so it's clearly not in quite tight enough. And that was my worry. The neutral just doesn't necessarily sit in the cage clamp alongside a 25mm tail in a satisfactory way with this product, and given enough time I suspect I'd have been called back to a melted terminal. To be fair, had I bothered to read the Luden instructions, I would have seen that it's only intended to be connected in parallel anyway. This product, as it stands then, isn't really suitable for inline installation, unlike the expensive Wilex thing I also mentioned in the last video. When Luden called me, they did say that they would perhaps look into a means for this to act as a through device with some kind of termination assembly perhaps on the bottom of the main switch to accommodate both the device wiring and the main tails, so watch out for possible changes there. And this is where I fell down on site. I'd envisioned inline connection of the Luden board, figured it wouldn't do, and I connected it in parallel as the Luden gods intended. All was well, and in an inebriated state last Friday night I wazzed the footage through the video editor and left it to upload in the small hours. Everyone was happy. Just as I was biting into the old hair of the dog on Saturday evening, a YouTube user going by the moniker of Number 33 posted a short comment indicating I'd got my facts wrong regarding line length. I'd stated that the line length from the MCB to the SPD was all important, whereas they indicated the line length external to the SPD enclosure to the Henley blocks also had to be considered, all of which left me reaching for the regs book instead of the bottle opener. Most unsporting. For some urgent fact-checking, I scrambled onto the roof of my international headquarters and fired at the DSES twat signal, which I only use when I ballsed up and need advice from electrical superheroes. And who should respond via Twitter? Why, only Megavolt himself, the mighty JW, aka the Ampere Avenger, he who is about to cross the 100,000 follower threshold on YouTube at the time of this here waffling. The Great One confirmed I was in the wrong and provided a link to a beamer guide which made for interesting reading and details why lead lengths are so important. I've linked to that in the description for those who want to know more. But 36 hours before all that, I mistakenly believed the tail coming into the board didn't count towards the maximum 0.5 recommended length prescribed by regulation 534.8. I don't know how I made that error. It's pretty clear when it says there in black and white the total wiring length of conductors between connection points of the SPD should preferably not exceed 0.5 metre and in no case exceed 1 metre. I erroneously took that to mean the connection point between the SPD and the MCB adjacent to it, but it's the connection between the input of the SPD and where it splices into the installation which we need to measure, and in this case that's at the Henley block. Still, it's nice that the YouTube community was so forgiving of my error, even if I did open the video scratching at my itchy junk, but nobody has a problem with that, right?
The fact it makes you look like a brain-dead sexually repressed woman repeller who is probably gay. Yeah, it's great.
Oh, piss off, sugar tits.
As I did correctly state in the last video, we also have to consider the connection from the earth terminal of the SPD back to the earth bar within its enclosure. But where we've routed our protective earth through the SPD enclosure, then we don't have to count the length of the protective earth conductor back to the head, or from our intermediate SPD earth bar to the main earth terminal in the CU of the installation we're trying to protect. If we don't break into the main protective conductor at the SPD like this to create an intermediate earthing terminal as permitted in regulation 534.9, and we instead send our protective conductor back to either the head or to the consumer unit, then that route back also counts towards our 0.5 metre recommendation and the 1 metre maximum limit, and therefore flushes it right around the ruddy U-bend. So for a parallel external enclosure, it's very difficult to keep that wiring limit down. The internal connections within the Luden board exceed 20 centimetres before any external wiring is even added. This thing would have to be right on the output of your Henley blocks, with tails less than 30 centimetres long for you to stand any chance. In my case last week, my tail was probably around 60 centimetres, so it's not ideal, but it's within a metre all in, so I don't propose to go back and make drastic changes there. What about if we want to install a CU with a built-in SPD on the end of a 3 metre tail? How can we keep the SPD under the 1 metre maximum limit if the tail to the board already exceeds this? Well, again, it's in the wording of regulation 534.8, which, as you may remember, starts mounting up the millimetres only from the point where the SPD is supplied by the installation. So in this case, that would be where it connects within the CU itself to the main switch or an MCB, and where it connects to the earth terminal, easily within a metre when inside the enclosure itself. So in this configuration, we don't care about the length of the tails.
What difference does a few centimetres make? I heard some of you cry in the comments.
Well, the beamer guide provided to me by John Ward has a graph on page 42 that shows how long cable length and failing to bind the cables together to reduce their magnetic fields can drastically drag down the effectiveness of an SPD. Having the tails run inline through the SPD in a separate enclosure is perhaps best, as tail lengths don't matter if we're passing through it, rather than our SPD enclosure being in parallel to the installation. We could house the SPD inside the consumer unit we want to protect, but I'd like to flag Paul Meenan from E5 Group, who raised the concern on Twitter that they could perhaps cause damage to surrounding equipment in the event of a catastrophic failure, and that a surge is best arrested before it gets to the board. So something like the Wilex isolator mentioned at the start of last week's video then perhaps. 140 of your British pound coins with VAT at TLC and can be fitted onto any domestic supply according to this point of sale. Except, isn't that an insulated enclosure?
Under Regulation 421.1.201, introduced in 17th edition Amendment 3, domestic switchgear and similar assemblies were to be housed in enclosures of non-combustible material, which is why we've all had to switch over to horrible steel consumer units. If this Wilex malarkey is supposed to be the cock and balls, how can I fit it and still comply? Well, it's a bit of a nonsense. In my last video I naughtily pulled the main fuse as there wasn't an isolator on site, but had I called in the DNO or the supplier to install such, it would have been a 100 amp switch in a plastic box just like this one, because, well, that's what they're still installing. Oh sure, they're not working to BS7671, but it seems daft to me that their cutout smart meter and isolator can be enclosed in plastic, but if I want to install another isolator 50 centimetres further down the tails on the client side of the installation, I'm expected to stick it in steel.
If I wanted to install this Wilex product, would I really give a shit if it's in a plastic box, so long as it's installed according to the manufacturer's instructions and the terminals are torqued up correctly? No, probably not. It's made for the job, it's built to British standards, and if it makes for a better and safer installation, then I wouldn't hesitate to use it. If you're worried about loose connections in plastic enclosures, take a look at some of the smart meter installations that are going in. Now, the only problem I have with this thing is the price point, and while I'm sure not all SPDs are made equal, and there are some features of some that may be lacking in cheaper models, so long as they're built to British standards and do the job they say they're supposed to do, it's hard to justify spending twice the money on one over another.
Sticking with the subject of enclosures, I'd like to talk type testing.
I stated in the last video that I'd installed a non-Hager SPD into a board for one customer. I mistakenly said it was the SY2D product, but it was actually the rebadged Luden variant that I've been showing here. Simon was one of several people who pointed out in the comments that the DIN rail was a standard put into place to allow the mixing and matching of devices, and indeed it seems to not be a problem in other countries. In 18th edition, Regulation 536.4.203 wandered along to piss on the party by effectively stating that the manufacturer decides what can go into their enclosures, and if you want to deviate from that, then you accept the liability for it.
For devices that sit on the buzz bar, this is understandable, although these rows of spare devices behind me here all sit happily on the DIN rail together. Their cage clamp terminals on their bottoms, which connect to the buzz bar, can vary wildly. Compare, if you will, this CP Fusebox RCBO with this Hager RCBO, and you can see that if you tried to shoehorn one into the board made for another, then the buzz bar would have to distort, putting mechanical pressure on it, the device and any neighbouring devices, because these cage clamps just don't line up properly when they're sat on the DIN rail. It can even be a problem across the same brand. This Luden 6kA MCB for domestic purposes and this Luden 10kA MCB for commercial purposes also have cage clamps which don't line up at all when they're sat on the same DIN rail. If a device won't sit flush on the buzz bar, then there's the risk the cover won't go back on, and some idiots might hack out the cover to get it to fit in a way the manufacturer certainly wouldn't approve of, and possibly also with a loss of IP rating. When it comes to SPD devices like this fellow, it sits nicely on the DIN rail and it doesn't connect to the buzz bar, so it ought to fit into pretty much any enclosure without anyone having to hack it. This is why Surge Protection Devices Limited say that you can use their products in most boards. It's a passive device, it shouldn't cause an issue and it shouldn't degrade the safety, but Regulation 536.4.203 does make it your responsibility if you make that call and fit it into an enclosure of another brand.
YouTuber Stephen Law raised an excellent point, unfortunately, which was to ask how effective my SPD would be at the source of the installation if the surge was coming from something like the pool pump, which is already at the consumer unit end on the final circuit side.
You know, I might be barking up the wrong tree with this thing. I put it in because of an unusually high failure rate of Philips LED lamps that we just don't see anywhere else, which makes me think it's a site-specific issue, although it may have been a bad batch bought from the wholesaler for all I know. If the surge is coming from the back end of the installation, then maybe my SPD at source will be less effective. I don't know, but surges from equipment on final circuits should be smaller in magnitude than what might come in from the network. Honestly, this might prove to be poppycock, but we put one in at the beginning of March on another site that was also seeing LED lamp failures, and we haven't been called back since. This was a cheap and quick thing to try here, so we'll see what happens. A couple of commenters queried if it were possible to remove the removable module from the connection housing without the use of a tool. So let's just try that from here, shall we? And oh, there we go, we are disconnected, but it won't physically withdraw from the casing. I can't twist it out either, so it's not possible to completely remove this without using tools to open up the enclosure, and therefore it doesn't leave any live parts exposed or open up the IP rating in the front of the thing so that you can get a finger in to touch a live buzz bar or anything like that. We do have these stops on the casing that prevent it from fitting through the front of the case here. There was some question on how my installation works when connected in parallel with the consumer unit I'm trying to protect.
If you think back to your GCSE physics days, you may recall that voltage is the same in parallel across a circuit, so a 500 volt spike coming into the installation will be presented across all outputs from that Henley block simultaneously. Both the SPD board and the main consumer unit will see the incoming voltage rising at the same time and by the same amount. It's not possible for different voltages to exist on the different sets of tails, as they're common together at the Henley block. As the voltage rises above the threshold of the SPD, it shunts the excess voltage to earth so that the voltage on both sets of tails drops accordingly. It reacts very quickly, under 25 nanoseconds according to my blurb, 1 nanosecond being 0.000000001 of a second. That's pretty damn quick.
When it comes to operation and lifespan, some people were under the impression that they're only good for one event and then they're blown. Inside an SPD, my understanding is that you may have a metal oxide varistor, a gas discharge tube, a transient voltage suppressor, or a combination of these. They all have the job of shunting an overvoltage of a short duration to earth and can do so many times for short order events. A suitably high or prolonged overvoltage event can cause them to break down, and from the teardowns I've seen on the STG electronics and eFix channels, it shows that a failure which causes an overtemperature event will melt a solder joint to release the mechanical flag indicator in the window of these things and break the connection internally. Some of these devices, like the ones built into the consumer units that hang off the main switch, have no backup overcurrent protective device, so they're only protected by the 60 to 100 amp fuse in the service head. This means if they fail short circuit, you're relying on them getting hot enough for that solder connection within to act as a thermal fuse and melt before the overcurrent plops you into darkness. In the case of the Luden product, there's also this localized 32 amp MCB, so if the bum hole is blown out of the SPD, you still have this localized breaker between it and the supplier's fuse. Several of you highlighted another model in the comments, and the nice thing about this one is the price, which is even lower than the Luden at £62.60 with VAT, and I'm indebted to CP Fusebox for sending me this sample example. So let's pop it open and take a closer look. Okay, we've got a lot of space to play with, which is nice, and we have 32mm knockouts above and below the main switch, which is just where we want them. There's also a tail clamp here to keep the tails in place and in line. This model comes with two instruction sheets, one for the SPD device itself, the other for the whole assembly. The SPD sheet shows that the device is to be connected in parallel with the installation, as we know, but that's just the device, not the assembly as a whole. And if we look at the second sheet, we can see that the assembly is made to be connected in line with the installation. So you'd install this in place of an isolator, and the main switch in here would act as such. As we saw earlier, being in line with the installation means we don't have to worry about lead length. The measurements for such would just be the brown and the green yellow wires inside this box, which easily clock in at under ½ a metre, even though there's a few more centimetres length than needed on them. But what about the main switch clamping two wires again? Well, the thinner wires here are crimped, so if I undo the neutral again, we can see that they've got the ends crimped, unlike on the Luden board, so hopefully they're less likely to pull out. But again, let's torque it up to 2.5 Newton meters and see what we can see. Yeah, that's nice and secure. That's not coming out at all. So this is better suited
to work as an inline board, but again, to be fair, the Luden isn't made for that. Personally, I prefer it if the tails weren't sharing a connection in the cage clamp with another wire, and if there was some other kind of assembly to allow the two to individually be connected and torqued up, but it does seem like it's stable here and suitably secure. There is an oddity on the instruction sheets that I've got. The enclosure sheet states it's suitable for TN and TT installations, but the sheet for the device itself states that it's for TN systems only. CP Fusebox tell me that it is suitable for TT and that the instructions have been modified since this was printed. On a TT, you'd install this device before any time delayed RCD. No mention is made of overhead supplies on the CP paperwork, but the Luden states that their product is not suitable for installations fed from overhead, although it can be used on both TT and TN systems. Let's perform a test on this thing, both to show it in action and to show how it can affect testing when you're out in the world. I'm going to be using my MFT Pro for this test on the insulation resistance function. Unfortunately, the camera doesn't pick up the screen very well here, so I'm gone high tech, and I've taped another camera to a power supply here, which I'm hoping will balance on there and allow me to record the screen. Let's press record on that. And then maybe I can do some picture-in-picture wizardry on this video editing here. Let's try that, shall we? Oh, yes, that works rather well, doesn't it? Okay, jolly good. So we can see the screen and we can see what I'm doing. I'm going to switch to insulation resistance. One probe is on the earth bar, the other probe can go into line or neutral on here, doesn't matter. And I'm going to shove a test voltage of 250 volts into there, which I expect the surge protector to ignore because it should be quite happy with 250 volts. And indeed, we're off scale high on insulation resistance at over 499 megaohms, so the surge protector has completely ignored that. If I were to whack that voltage up, and let's put it up to 1000, shall we? We don't get to play with 1000 very often, so we're going to simulate what happens when 1000 volts now goes into our surge protector. And of course, what we expect to happen is the varistor in here should drop its resistance and dump the over voltage to earth, giving us a crap insulation resistance reading to earth. So let's see if that's what happens. And sure enough, there we go, 0.14 megaohms, a definite fail. Now, doing this test isn't going to damage the surge protector. You can see that the flags in here are still showing green. The current is far too low for it to cause any over temperature to melt the solder in here. That would trigger the over temperature function, causing the device to fail. So we're not going to damage it, but if this is built into, say, a board and you're doing insulation resistance testing and you neglect to, for example, disconnect the neutral or whatever, or if you're trying to test the whole board at once, which is a bit weird, why would you do that, then the SPD can skew your results. To be honest, most of the time you're going to get skewed results is when you've got something like this still plugged in that you've neglected to take out a circuit, a surge protected power strip, or an item of equipment that's got a surge protector built in that you've forgotten to unplug before you started doing your testing. On a different matter, regarding the sealed Henley blocks shown in the last video, Joe Southgate was the first of several people to say that these are sealed not for anti-tamper reasons, but to prove that they were correctly tightened and installed. So if an incident occurred afterwards from, say, a poor connection, it could be proven that the installer wasn't at fault if their seals had been removed. So that was interesting to note, and it makes sense. Before I sign off then, let's have a look at the rearranged Luden board, and I've shuffled it all around, as you can see, so the main switch is now on the left, which puts it where our tails glands are. So what does that mean, having to move it around on the DIN rail like this? Well, now the SPD itself is adjacent to the MCB. There was a gap between them before, and I don't know why that was, whether that's by design or whether there's a reason for the surge protector to not be right next to the breaker. I'm not sure. I've managed to trim down the line because we've closed the gap. So I've managed to reclaim about 4 centimetres of wire off the line, but I've had to extend the earth. So that's the original earth tail that came with it. And you can see I've had to, what I've lost on the line, I've gained on the earth. So in terms of the wiring lengths, it's as it was before, but it's now rearranged so that when I go out to site to install this next time, goodness knows when that will be, it should be in a position where it's easier for me to install and I don't have to mess about with it as much. So there we go. Hopefully that makes things a bit clearer on the installation of Type 2 SPDs. It certainly does in my head. And remember, I make these mistakes so you don't have to. Thanks for watching. See you next time.